everyone. Welcome, welcome. I see Brecht is here, Proto is here as well. Let me make you guys speakers. I see Brecht is speaker already.
Hey guys.
Hey Brecht. Yep, your mic is working. Everything's good. Vitalik is coming in a minute or so. Proto, hello, you there? Let's check your mic.
Hello.
Yep, we can hear you. Have you here. Great to have you here.
Great to be here.
Okay, we're waiting for Vitalik. He should be here any moment. I see a lot of people from our community. I see our CEO Daniel here. Hey Daniel, Erickson, our community advocate, Lisa, our researcher, Korchinski, our Discord mod, a lot of people from the community. So welcome everyone. Yeah, great to have all of you here. Okay, Vitalik is here, I see. Vitalik just added you as a speaker. I see it's connecting, so let's just wait. Okay, you're a speaker now. Vitalik, can you say something? Just check your mic. Nice. Thank you for being here. Okay, I guess we can start. Everyone's mics are working. Yep, so hello everyone again. Thank you for tuning in. I'm Archie, aka Umede. I do community and communication stuff at Taiko, and I'll be moderating this panel. And apologies in advance for my voice. I've been sick with COVID these past few days. But not sick enough to miss the discussion we're about to have. And speaking of today's discussion, we're going to talk about multi-proof systems for rollups. We'll try to understand what these systems are, how they work, maybe agree on the most elegant way of doing multi-proofs, etc. And at the very end, I hope we'll have 10 to 15 minutes for a few fun questions, just to make the panel a little bit less technical, and maybe get to know our speakers a little bit more. So I know that there's no need to introduce our speakers today, but still, if you guys could briefly say who you are, what you do, and maybe what you've been up to lately. Brecht, maybe let's start with you.
Sure. Thanks, Archie. I'm Brecht. I work at Taiko, and so I'm mostly focused on the ZK development of zkEVM. So we've been working with the PIZ team on that for the last 2.5 years. But I also do some protocol stuff, and happy to talk about multi-proofs today.
Thank you, Brecht. And I probably can call you a frequent guest of our Twitter Spaces already. You've been participating in almost all of them. So thank you for being here, sir. And Proto, a few words about yourself, please.
Hello everyone, I'm Proto. I work at OP Labs. At Labs, I work on fault-proof technology for Optimism. We have a draft of a MIPS proof, and then we also have a RISC-V proof in the works. And then we're also developing ZK proofs with 2 different external companies. So this is heading towards a multi-proof.
Okay, great. Thank you, Proto. And I guess one thing to add is that Proto is the co-author of EIP 4844, also known as Proto Danksharding, which is going to significantly lower transaction fees for rollups. And at least we at Taiko are very eagerly waiting for EIP 4844 to go live on mainnet. So thank you for being here, Proto. You're a legend. And speaking of legends, we also have Vitalik with us here today. Vitalik, tell us what you've been up to lately. Maybe tell us whether you're a cat person or a dog person, and if you're up for your own challenge, maybe try to do it without using the letter O.
I like cats and I like canines, but if I had to decide, I will with p greater than with p near 1, say crap, I said 1. Say cats slightly greater than canines. Yeah. Okay. This is yay. I like the letter challenge. But well, yeah. I mean, figuring out how to replace the word probably is hard. Let's see. What have I been recently thinking about? I mean, admittedly, like less in this particular space, but probably more in account abstraction and some like proof of stake stuff and like basic long-term proof of stake research. And like, what are some ways in which it makes sense to like get out, I mean, like both things like single slot finality and like other things that we care about, but at the same time try to respond to some of the staking centralization concerns.
Okay, thank you, Vitalik. Yeah, the letter challenge is very hard. Yeah, thank you. It's an honor to have you here. Okay, gentlemen, thank you. I guess we can start. So I thought it would make sense to start by giving some like background on what proofs are in the context of Ethereum rollups in general. So maybe Proto, you could please give us a short intro in what proofs are and what types of proofs there are and like why rollups need them in the first place.
Right, for sure. I can give you an introduction. So with rollups, what we have is basically a off-chain state transition, a function that helps users transact without going through the layer 1 EVM. Now, rollups are secured, or their ordering is secured through the data of the layer 1. So that we're addressing with Void for 4 and other data improvements. But then it's decoupling the execution. And decoupling execution means that to get the outputs of the state transition, you need a proof such that you can trust the outputs as a user on layer 1. And so these different proof systems enable users to utilize the rollups, benefit from this off-chain execution, decouple from layer 1, but then still bridge back to layer 1 when needed.
Okay, thank you, Proto. Yeah, makes sense. And can we now try to like define the problem of having just only one proof to prove what's happening on L2? Like, what's wrong with that? Like having just one proof, and why do we need multiple proofs? Maybe Vitalik, I'll throw this one to you.
The biggest risk that I see with rollups, and like the biggest thing that would prevent me from feeling comfortable in like throwing, let's say, tens of millions of dollars into a rollup is software bug risk, right? Like the risk that there is something wrong in the admittedly very complicated logic of a fraud-proof system or a zkEVM that's covering an entire EVM that could lead to an attacker exploiting that bug and just draining all of the assets inside of that rollup somehow. And like that would be something that is just like so easy to do, right? Because all that you need to do is like create a bug that just like somehow leads to one balance in one account somewhere being much higher, and then you just like go and withdraw it, right? And so one of the core ideas, and this is an idea that Ethereum itself relies on at layer 1, is instead of relying on one client and one software implementations, to have multiple software implementations so that for an attack like that to be possible, the attacker would have to find not just a bug in multiple implementations, but like actually the same or similar bugs in multiple implementations, where those bugs like go in the same direction and enable the attacker to like do something invalid inside of the layer 2 and get it confirmed inside of the layer 1. And this multi-client approach definitely has had a history of saving Ethereum in previously. So, like for example, there was a situation a few years ago where I believe it's like an old version of Geth got forked off the network, but we only ended up like losing, I think, a tiny amount of I think it was hash power back then. And even before that, there was one bug that led to a chain split instead of an invalid thing getting confirmed, and then the chain split just got resolved by developers. And then in 2016, during the Shanghai DOS attacks, there were basically the attacker just repeatedly found many bugs in both of the major Ethereum implementations that massively slowed the network down, but the attacker never managed to quite find a bug that completely stopped Geth and completely stopped parity at the same time. And so, because there were multiple implementations, that actually allowed the network to keep moving forward, despite like bugs in individual implementations being found literally every other day for a month. So, like that kind of insight, like basically, decentralization between different implementations that cover for each other and that reducing the total risk is, I think, the big reason why multi-provers could similarly reduce risk for coins inside of layer 2s.
Okay, yeah, makes sense. And you mentioned the clients, L1 clients, and how having multiple of them like reduces the risk of attacks. So do you think that maybe in the future we'll have like multi-proofs evolve from being like purely used for L2 rollups to maybe being somehow enshrined in L1 itself? Like, and if so, what do you think this process of adding like multi-proofs on L1 look like?
So this is an interesting topic because I actually have this draft post that I think I just haven't published yet that talks about a way of enshrining basically zkEVM proving and making it be a layer 1 feature. And one of the big philosophical arguments that this runs into is basically, do you choose a fixed number of proof systems and a fixed voting algorithm and kind of enshrine that into the protocol, or do you make it open, right? And Ethereum is open, right? In the sense that like anyone can go create their own Ethereum clients and they can run the Ethereum clients, and the distribution of clients can change without any permission from the developers. And this gives us a lot of freedom in how we respond to bugs because, for example, let's say there's a chain split where 40% of the network goes in one direction and 60% of the network goes in the other direction, but then it's just obvious to everyone looking at it that the direction that the 40% is taking is actually the correct direction. Then like we can go and choose and just go with the 40% direction, right? Like it's not a majority vote. And that's not a property that you would have if you start enshrining like multiple proof systems in what I call like a closed way, where you have a fixed number of them. And so that's why in this draft post that I haven't published, probably should get around to publishing it at some point. Actually, I'll just get it out in the next couple of minutes because why not? But basically, one of the challenges is that like making it open is possible, but it becomes much harder, and like that's something that can only be done at layer 1, right? But then if you do it at layer 2, then like you pretty much have to be closed because it's a contract. And if you, because like a contract just like has to give a particular defined output, and like contracts can't appeal to Ethereum consensus to solve problems, right? But I think if we start trying to make it an enshrined feature, then there's like good rationales to try to make it be open instead of closed, but like that has these extra engineering challenges to it. But like, yeah, that's like the thing that I would not want us to regress on, right? Like, I think if we just say we're going to have a specific list of like provers that are acknowledged at protocol level, then we are kind of regressing from being an open multi-client system into being a closed multi-client system, and I think that has costs.
Okay, perfect, Vitalik. Looking forward to the piece you're about to publish. I want to take a moment to maybe go back to the definition of multi-proofs, and to me, it does sound a bit like vague, the term. So I thought that like probably like multi-proofs can be related, to having multiple prover entities in one prover network. It can also mean like multiple proofs per block, different types of proofs, or maybe some sort of a combination of all of the above. So Brecht, maybe you can help us understand a little bit, like what do we usually mean when we say multi-proofs, and where we should maybe put most of our focus.
Yeah, sure. So I guess similar to like execution lines for Ethereum, where they use like different languages to write the client, and you have like different teams that have their own separate implementation. It kind of like makes sense to do it like that, because that's kind of like makes them separate. And you also have like by using different languages, you have like different attack vectors, or like different kind of like bugs that can show up. So that's kind of like one nice way to add like diversity. And I guess like a similar thing for like the proof that we use on like a rollup is that you have like all these kind of like different snarks. For the ZK stuff at least, you have like different kind of like snarks, starks, kind of like all these different proving systems. But then you also have like some other like interesting things, so that are not directly like directly dependent only cryptography. So then you have like these crypto economic systems. So for example, like the optimistic one is one of them. So you have like these fraud proofs where people can try to challenge an invalid state transition, so you don't have to actually have the proof there to begin with. But then you also have like something like staking, which is kind of like you kind of like just have like a large value set comparable to like an L1 that just attests to the correct state. And then there's like lots of money basically backing this kind of like the correctness of that block hash. So you kind of like can divide them in pure cryptography and like crypto economic kind of like systems. And like I guess SGX is also kind of like an interesting one, like these trusted these TE environments, which I guess is kind of like somewhere in between maybe. But yeah, you have like lots of different ways to be able to attest that something is valid. But then you also like fraud proofs that attest to something that is invalid. And I guess there's like lots of different ways you can try to try to implement these to kind of like increase the security of your system.
Okay, thank you, Brecht. When you say like multi-proofs, you immediately think of multiple proofs, and I was just wondering, is there like an optimal amount of proofs within a multi-proof system that makes the most impact, and does having multiple proofs equal to like having more security, or is there like a point where too many proofs can become an issue? Maybe Proto, can you take this one?
Sure. The multi-proof system really means a trade-off between safety and liveness, where with a singular proof, you basically put everything on that one proof. Whereas with multiple proofs, you can hedge and you can start making trade-offs and say with a certain quorum get through consensus what the output should be on layer 1. Now, the more proofs you add here, the more you can customize this quorum. Whereas if you only had 2 proofs, you would basically only have the option of like trusting 1 out of 2, or maybe going for safety over liveness, where you have to have both proofs pass, and if one of them or both of them don't resolve to an outcome, then cancel resolution through proofs and try and solve it through the social layer. But yeah, more proofs would add more granularity here and prevent any single point of failure from becoming too big of a problem for the resolution of the proofing.
Okay, makes sense. And by the way, guys, if you want to respond to what your colleagues say, or I don't know, want to comment or have follow-up questions, just ask them whenever you want. Vitalik, I don't really know a lot of about zkEVMs, but my team was like very eager on making me ask you questions about zkEVMs, like your just general thoughts on zkEVMs, like the current landscape, and like do you have any thoughts on zk, how they can have a role in the multi-proof systems?
I mean, ZK provers are like one of the basically three types of provers, right? The other two types are optimistic and trust based, and so that I think you just any realistic multi-prover system is going to have to involve them, and I do expect that in the long term they will, and in the medium term they'll continue getting better and better, especially once we start optimizing for latency much harder than we have been so far, which is something that's definitely going to become more possible with some of these more like recursive and BCD type approaches, especially as compared to the more monolithic ones that the EVMs started with. I mean, it does feel like it's a rapidly evolving space, and so I think what my main opinion on them is to just not have too many assumptions, because the assumption might easily end up becoming false 12 months from now as we have new and better technology, right? Like even the underlying proving systems, for example, like recently there's been a lot of interest in like what Justin calls the lookup singularity, and focusing less on polynomial math and more on hyper-optimizing lookups. And like if things actually go in that direction, then the best way to write a zkEVM is going to be very different in the future, right? And then there's the question of like what is the underlying proof structure, and like if you do recursive proving, then like what things are you recursive, like what are the subproofs for, and that ends up being influenced by computer architecture. So there's a lot of different things that are rapidly changing. I think the way that I just think about it is that we know that Ethereum blocks can be proven, and they can be proven with a particular level of quantity of a compute and a particular latency, and I expect both of those to just continue, especially the latency, to continue getting much, much better over the next couple of years. And as those parameters get better, then different kinds of options on the protocol side become more and more possible.
Okay, thank you, Vitalik. I wanted to move on to optimistic rollups and maybe see what Optimism does in terms of multi-proof. So Proto, I guess like one of the most common comments addressed towards optimistic rollups is that they use fraud proofs, and I don't know why, but they're like generally seen as less secure of a proof than zk proofs. So maybe a couple of questions. Do you agree with this? And I also know that you are doing something with multi-proofs at Optimism. So maybe tell us a little bit about what you're up to on that front.
Right, there's a lot to unpack here. So in terms of latency, proofing, and the multi-proof system, there are various questions in there. let's start with like what we're trying to get to. What we're trying to get to is like a low latency proof that we can rely on as a rollup to post our outputs to layer 1. Now, if we compare rollups today, we're not really getting there yet. No rollup is there yet, because we all still rely on a singular proof. And so we have to put constraints on that. We have to put checks and boundaries on that, because this proving technology is all like so new. So some ZK rollups today, they have to enforce like an hour or maybe even a full day of delay until they can trust the output that has been proven through a ZK proof. Now, with optimistic rollups, we have a 7-day window. Now, this window does allow for basically to incorporate any proving system in the multiproof, as in latency is not the factor here anymore. Like, rather we prefer safety and incorporate more proofs rather than trying to choose between the proofs just to get the lowest latency one. But there are definitely trade-offs there. And as one might say, the proof doesn't define the rollup anymore. Rollups can adopt multiple proofs. They can adopt both ZK proofs and optimistic proofs. And I think this is the top priority, to get that safety, to get that level of confidence that, you know, the bridge cannot be exploited through a singular bug in one proof. That's the important part here. And then with optimistic rollups, the comment you made, like whether or not it's more secure or not, the assumptions are different, but in practice, I do think of them as more secure, just because of the simplicity. Simplicity is important. The more complexity you add, the harder it's to verify the correctness of the system. And ideally, we hedge by relying on radically different proving systems to rule out any possible bugs there.
Okay, makes sense. As I understand, you are combining ZK proofs and optimistic proofs for your multi-proof framework, right?
Right. So a proof is modeled as a game in our system, where the game can resolve after a certain period, given certain conditions. And then we make this very modular, where a game can consist of subgames. It can involve different proofs to resolve until you unlock the game as a whole to resolve. And so you can compose different proving systems, is the idea. Now, in the monorepo, you'll find a dispute game factory. It's a contract that can spawn other games. And the idea is to add more and more game types to this factory, such that you can compose the security of your rollup. And then ideally, you have a ZK proof in there, an optimistic proof in there, and various different versions of those.
Okay, thank you. I guess one proof type we haven't talked about is SGX. Vitalik, do you want to maybe share your thoughts on SGX? Taiko is going to like launch our testnet with SGX proof. So yeah, your thoughts on it.
Yeah, I mean, SGX is like one of those challenging things because on the one hand, it almost feels like a cheat code. Like you can just put in computation, it runs like not too much more slowly or more restrictively than regular computation, and you just like get back a signature saying that it was done correctly. But the challenge is, of course, like you have to trust the manufacturer, and CPMs get broken all the time. And so I think my general philosophy on trusted hardware has been that like it's good when it adds security, but it's bad when it becomes a dependency for security. So like one example of this in a different space is in account abstraction. One of the things that some of the recent wallet providers have been getting excited about, like I know Sol Wallet has been doing this, I know Clave has been doing this, and there's others, is using the keys inside of trusted hardware modules in order to like as the private keys that hold assets. and this is why there's the whole desire to put SecV356 R1 into layer 2s and eventually into Ethereum, because that's the curve that is used inside most of these TPMs. And like with that use case, the trusted hardware adds security, because if your phone gets hacked, then like there's still this extra layer of protection around your private key. But if the TPMs end up being totally broken, then like as long as your phone or your computer or whatever is fine, like you're still fine, right? And but then on the other hand, like if you just go and make a chain that says like, hey, in our chain blocks are verified by using SGX, then like that whoever can like break SGX can just like break your chain and print infinite coins, right? So I think I'm in favor of using SGX as one factor in an M-event system, but I am not in favor of giving SGX enough power that if SGX is evil, that would like actually make them able to stop the chain or steal coins.
Okay, and would you see like SGX as a viable proof in the long term? Like, would you still?
I would say as a sole proof system, I would say flat out never. But as I said, like as a member of A1 of N that could exist alongside other things that provide security, like absolutely even today.
Okay, great. Brecht, maybe you can talk a little bit more about the SGX side of the things and like what we've been doing at Taiko. Like how do we view SGX as a whole?
Yeah, sure. So yeah, I think like SGX is like pretty cool because it kind of like it's kind of like if Vitalik said, it's kind of like a cheat code, or it kind of like SGX kind of like works if like the ideal ZK, like if ZK would be ideal because it's kind of like it's like very cheap to generate, and also like the finality is like very strong, like a very quick, so there's like low latency. So both of those properties make SGX like very interesting to use, especially the low latency part, because well yeah, if you have like all these L2s and they have to be able to like communicate with each other, then the low latency thing is like very important to be able to get there. And so there's not many proofing systems that you can actually use today that give you those properties. I think the only ones that are available are SGX and kind of like this kind of like some kind of like proof of stake network or some kind of like crypto economic system that can give you like this very fast finality with still like very strong guarantees that everything is done correctly. So I think that's very cool and also like makes certain things already possible, although not in the ideal case, because yeah, obviously the ZK case is the best case. But yeah, still SGX also allows us to reuse like these code bases. So we have these light execution clients that are written in like a Rust or in Go, that depend on like REVM or like Go Mini, and you can actually already like run this in SGX, and you are also now able to run this same code in like a zkEVM. So that allows us to reuse kind of like these different light execution clients, same code base, and just target different proving systems that are like significantly different. So already like very diverse. So already add like lots of security to a rollup. So I think like yeah, it nicely fits into this like multi-prover system. And okay, like Vitalik said, you don't want to just use SGX, but like as one extra proof, it's like very valuable.
Okay, makes sense. And Proto, have you considered adding SGX to your multi-proof system at Optimism, or like what types of proof are there? Like, I know that there's ZK, SGX, fraud proofs. What other types have you considered adding anything else?
We have definitely looked at SGX. In the end, I think SGX doesn't meet the criteria to be the sole solution. But like Vitalik said, when you put it in a quorum, it can improve the granularity, the ability to detect faults in the other proofs by having more options. So I think there it's great. Generally, what we are trying to do is to keep it so modular that state transitions and proofs can be combined such that you can, like choose the different state transitions, the Go, the Rust, or the other versions, and then combine them with different proving virtual machines like SGX or the different optimistic fault proofs like a MIPS fault proof or a RISC-V version. And by stacking it like this, you get even more options. And then when there's a fault, like a bug in one of them, you can detect it by running the other versions and comparing the results.
Okay, yeah, makes sense. And Proto, you mentioned that there's some sort of a game, a dispute game in your like multi-proof system. I think it's a little bit similar to what we call this like concept-based contestable rollup. We just published an article on this. Basically, it's just it's a multi-proof system with contestation on top of it, contestation mechanism on top of it. So maybe Brecht, you can give a brief overview of like what contestation is in this sense, and how is it like going to work on our next testnet?
So I guess like in the ideal case, you have your rollup is proven by all these different proving systems, and then again, if some of them you cannot generate, or ideally all of them kind of agree on some kind of like block hash for the L2 block, and then the rollup can like finalize, and then bridges can actually use this block hash. But yeah, if you have like different proving systems, then especially like the ZK ones, they're like pretty expensive to generate. So the proving itself can be expensive, and also the ZK proof verification on chain can be expensive. So depending on what kind of like properties you want your rollup to have, you might not want those costs to be applied to like all the blocks. So that's where we see like some kind of like optimistic system coming in, where you don't require all the proofs to be there for all the blocks. And so, for example, in the simplest case, you have like a minimum set of requirements per block. So that could be for example, like SGX that is required for each block because it's still like cheap and gives you some good guarantees that the block hash is correct. But then you have like this extra like a challenge game or contesting period where people can still contest like the correctness of that block hash using by adding like an extra bond to to challenge this block hash on chain, posting like an extra bond on chain or something like that, and then you can use like a ZK proof to verify that indeed like this block hash that was posted is incorrect, and you can actually prove what the correct block hash would be. So you have horizontally you have like different tiers, we call them, where you have like different these proving systems, but then also like vertically you have like these different like phases that you can go through of like this contesting of like, okay, you prove like a block hash is correct with SGX, but then it can still be like contested with like a ZK proof or something like that. So the benefit is mostly just to decrease the prover cost, but obviously it does add like extra latency to the system. So it's kind of like a trade-off that you have to make for your rollup or your app chain or whatever you're building on what kind of like proofs you require as a minimum, and then you can still use all the proofs as kind of like a challenge game on top of it.
So as I understand, like the main difference between the classical optimistic challenging and this contestation thing is that there are like different tiers of proofs. So maybe you can, for example, like what types of like proofs are considered as the most secure ones, and like how are these like tiers determined?
Yeah, it's kind of like subjective. So it makes most sense to kind of like order them in like how expensive they are to like generate and also to verify on chain. So for example, like an SGX proof is very cheap to generate on chain, off chain, and also very cheap to verify that the signature is correct on chain. So this would be like a very good candidate to have like as a basic tier, because it doesn't add a lot of cost to your rollup. On the other hand, you have like ZK systems where if you use like a zkEVM, then the cost to generate the proof is like very significant, and you also need like specialized hardware to be able to generate. You need like lots of like computing power at least to generate these proofs. and hopefully this will go down quickly in the future. But still today it's quite significant. So you first have to be able to generate that proof, to be able to contest, or like to be able to attest to the validity of like a block, and then you also have like the verification cost on chain to actually verify this proof. So that makes it like more expensive to do. So that would be like a very good option to have like as a next tier that is used as little as possible to keep the system cheap. So you have kind of like three different like phases, I guess, for proofs. So either you kind of like want to avoid the proof generation part and the proof verification part on chain. Then you have something in between where you kind of like still generate the proof, but you just post the proof on chain, but you don't actually verify the proof on chain. So I think they call it like naysayer proofs. And the benefit of that is like you still have like all the proofs available, so anybody can actually verify them on chain, but by default you don't do it. And then like the next is kind of like the default system where you generate the proof and also fully verify the proof for each time you actually need it. So yeah, there's like different trade-offs and like different like costs associated with what you're trying to do.
Okay, makes sense. Thank you, Brecht. Vitalik, any thoughts on this, on contestation, different tiers of proofs?
Different tiers of proofs. Yeah, I mean, I think, the version of this that I'm in favor of is like a version that basically says that, you have some like lightweight proofs that run normally, and as long as all the lightweight proofs are agreeing with each other, then things continue going forward in like a very high efficiency way. But then there's some like extra heavier proof systems that only get run when the something happens in the lightweight proof system, right? Like that approach to me makes total sense, and I think to me the thing that's important to keep in mind in these systems is like the mechanism, that like fallback mechanism has to be kind of robust by itself, right? Like it has to be a mechanism where people would feel comfortable if that was the only mechanism, right? And so like if you have like extra proof systems coming in that situation, then that's good. But then on the other hand, like for example, if you have like a kind of like ultimate oracle type thing where people just like throw ETH in, and whoever throws more ETH in wins, for example, then like that's like bad and destabilizing for reasons that I've talked about, right? But that's like just an example. So I think from a security perspective, the quality of like any kind of like multi-step system like basically is the same as the quality of like whatever the step providing the like final fallback is. And from an efficiency perspective, like the efficiency just is like whatever the efficiency is of the like fast like best case thing that you're running.
Okay, thank you, Vitalik. One question regarding booster rollups. This is a thing that our Brecht, our Gigabrain at Taiko came up with. I was just wondering, I don't know if it has like these booster rollups have anything to do with proving, but maybe Brecht can talk a little bit about like, are there any links between these booster rollups? Maybe you can shortly explain what these booster rollups are, and maybe is there a link between them and multi-proofs?
Yeah, kind of like a little bit because for like the booster rollup, so they get to shortly explain. So this would be like a rollup that can access like L1 data directly from like a smart contract on L2, and not only data, but it could also like execute L1 smart contracts that are deployed on L1 directly on L2. So you can like reuse the data, but also like the code that's on L1, and then just execute on all the L2s that have like this booster rollup thing going on. And so that makes it like much easier to start a rollup, because you don't have to like have like developers deploy their smart contracts to each L2 separately. So to be able to do this in like the best way possible, we kind of like have to prove L1 exactly the same on L2. So that means that if L1 hard forks, we should be able to just update the L2 at the exact same L1 block, to be able to execute the L1 smart contract code and read the L1 data exactly the same as the L1 does to remain fully compatible. Because, for example, if Ethereum L1 would switch to Verkle trees and our L2 is not able to verify data in this Verkle tree, then basically this wouldn't work anymore. So we have to keep in sync with L1 at all costs for this to work well. And so for us to be able to do this, we cannot really, it would be very challenging to still reuse the method that we were working on for the last 2 years. It's much more challenging to create custom circuits to be able to verify the L2 state transitions. And so the ideal approach would be that we could just use the existing execution clients on L1, because you need them to update the L1 network anyways, and just compile the same code to some kind of zkEVM. And then we just have to update the proofs on our smart contracts when the L1 hard forks, and we can still keep the L1 and L2 in sync in this way. And so that's kind of a benefit. This requires a type 1 zkEVM, and also it requires a system where we can just use compilation instead of handwritten circuits to be able to support this kind of things.
Okay, thank you, Brecht. Our time is running out, so maybe just the last question regarding multi-proofs before we move on to the bonus or the fun questions I mentioned in the beginning. So it seems that we all agree that multi-proofs are and will be a necessity rather than just a nice-to-have thing. So maybe what's your opinion on the most elegant way of approaching multi-proofs? I know, Vitalik, that you've talked about involving governance in these systems as well. So maybe based on what we talked about here today, what do you think would be the ideal multi-proof framework or approach with that? Let's start with you.
I mean, I'm personally a fan of doing simple and dumb things if you can. And so I think the simple and dumb thing is basically you make you take the system which would be protecting the coins if it was a single proof system, and then you make let's say 4 of those, one of them for each proof system that you want to make, or let's say 5 of them, odd numbers are better, one for each system you want to make, and then you just put the actual assets into a Gnosis safe that is a 3 of 5 multisig between those 5 things, right? And that approach is not gas efficient, but it's good at really minimizing the number of lines of code, the number of new lines of code that you have to write that is outside of the proof systems themselves, or code or code that is shared, right? But generally just pick some specific number of them and then go, and changing that should just be handled by protocol governance in the same way that updating the rules of the system to let's say stay up to date with the latest hard forks or whatever is done by governance, right? And then for that you just have a 30-day delay or whatever.
Okay, thank you, Proto. Anything to add here, or do you agree with Vitalik, or is there anything else you'd like to add?
Yes, I generally agree on trying to reduce the complexity of proofing systems as much as possible. The whole idea of the proof is to secure the assets of the bridge. And then if we're going to add a lot of complexity that is not diversified or hedged between different proofs on top, then it's not adding much. What we really need is a simple layer that then basically multiplexes, splits the responsibility between these different proofs. Although I do think that for layer 2s today, we need something more efficient than a multi-6 like system.
Okay, cool. Brecht, anything to add here?
Simplicity obviously is the goal. And I think if you use something like an optimistic approach, then you can come up with very elaborate schemes on how to most efficiently handle this. But if in practice the system is never used because the correct block hash is the correct block hash is always published on chain. There's never actually any fraud proving going on or any challenging going on. Then it's kind of you don't have to focus on actually making that more efficient. So Yeah, keeping simple, but also like trying to keep in mind like the latency and like the cost of it makes a lot of sense to me.
Okay, thank you, Brecht. Okay, I guess it's a good place to end our discussion on multi-proofs. Thank you very much, guys. Yeah, as I said, I have these bonus questions. You don't have to like answer them, but I thought it would be just fun if we could hear your answers. Very simple questions, just to get maybe to know you better, guys. Yeah, you can answer in any length you want, or you can just not answer the questions at all. But yeah. So the first question is, what would you do if you weren't in crypto? Like, what industry would you be developing your business in or your career in if you weren't doing stuff in crypto? Maybe Brecht, let's start with you.
I would probably still be trying to make some games or something because I tried for a long time and failed. So it's still something I have to achieve somehow.
Web3 gaming?
I think Web3 gaming, specifically just game in general.
Okay. Nice. Proto, same question for you.
Probably some type of security work. Reverse engineering is really what draws me into Ethereum. There's like a variety of so many different skill sets, and just to have a place where it's all important and gets you to some reward. Reverse engineering, like any type of security work, really just matches that very well.
Interesting stuff, Proto. Vitalik, what would you do if you weren't in crypto?
I still remember the things that I was getting into before I got into crypto, which were online education and AI. So very plausibly one of those.
Interesting. Online education. What would the education be about?
Education is like super valuable, right? Like there's all kinds of skills that we need to keep learning to keep being able to be do and be what we want to be in the world as it keeps changing. Like there's just being able to the thing that I ended up of course, when I got into crypto, a big part of what I ended up doing sort of was education, right? In the sense of like blog posts that were explaining a lot of like different topics in cryptography and protocol design. And the niche that I was filling there was basically that I noticed that there was a lot of like popular science writing that was accessible to the public, but that was totally inaccurate, and that there were basically these like god awful 48-page academic papers that seems to be optimized for being reviewed by the exact same types of people as the types of people that wrote it. And like I wanted to have some healthy thing in the middle that like explains how stuff actually works, but then it's actually accessible at least to people with a math background. And I mean, even just like doing that in a space other than crypto and like helping make important emerging fields just like more equal and accessible to people, and increasing the number of people who didn't take the traditional university path that would still be free and empowered to participate is like something that I could easily have seen myself also going into.
Nice to know that. Okay, second question. What's your favorite place in the world? A place that you like to come back, or you've been coming back to, or a place that just holds a special place in your heart? Brecht.
In front of my computer, I guess.
Yeah, I thought you were going to answer something like that. Okay, nice. Proto?
One place I would like to go back to, or that's a difficult one, Sydney. So when I first started at the Ethereum Foundation, I hung out at EdCon. I think it's a good place.
Okay, what's about Sydney? What do you like about it?
Well, the Sigma Prime team is there. There's a small Ethereum community. Pretty nice.
Okay, yeah, makes sense. Vitalik, your favorite place in the world?
This keeps changing every year, right? I mean, I like a bunch of places. Like, I think, in the U.S., it's probably either Denver or the Bay Area. In Europe, it's probably Berlin. In Asia, it's probably Taipei and Singapore. But I think there's lots of places that have like really interesting people and really good nature at the same time. And I think like those are the places that have both definitely really appeal to me.
What do you look for in a country or in a city when you visit? Like, what makes it a nice place for you? Is it the nature, the people, the food?
I mean, it's definitely a combination of all of those. Yeah, I mean, like those three basically already cover a lot, right? Though surprisingly, like there's pretty few places that cover them well, right? So like even on the nature side, like the average city in the world basically just has like many kilometers of like concrete and the occasional tree on the street, and you'd have to go very far to like find like a proper park. And I think Toronto is like uniquely good at that. Singapore is uniquely good at that. Some other cities are up there. In terms of people, I think like one of the things I always respected about Berlin is definitely the strong programming culture there. I think one of the, and then in like Taipei, for example, I definitely respect there's like this strong culture of just like people who really wants to learn and who are willing to actually like self-organize and like just like really excitedly learn and teach each other about like all kinds of things. Like it's the sort of place where I go and write a blog post and like there would just be some club of like 15 people that just like put it all into a Google Doc and have already been and just immediately start commenting on it. And like that kind of curiosity is definitely something that really appeals to me as well. But yeah, I don't know, different places are different.
Yeah, makes sense. Nature, food, people, the holy trinity, I guess. Okay, last question before we end. What's your preferred way of moving around? Do you like prefer to walk, use public transportation, drive your own car, take taxi?
I do not have a driver's license. My total driving experience is like probably like an hour total, and basically in parking lots mostly. But so I definitely like walking. I like running and all. I mean, when public transit is convenient, then it's definitely amazing. But then like there's
like a follow-up like question regarding walking. I think I saw you responded to an AMA question on Twitter, or maybe it was a Farcaster. The question like asked what's the largest distance you've ever walked in a day, and I think you said it was 100 kilometers. So I was just wondering if that was if it's true, like you walked 100 kilometers in like 24 hours, or was it like a typo?
Yeah, it was 113 in 22 hours, 35 I believe. But yeah, I mean, I set myself the challenge of walking from Waterloo to Toronto like many years ago, and then the first time I tried it, I think either I had the wrong shoes or something like that, and then my feet were like crazy hurting after 40 kilometers, and I gave up after 51. But then I just had this burning desire that like eventually I needs to be back and like finish the job, and so I finally did. But
That's
yeah,
great.
it was hard, but it was also a good opportunity to like listen to the all 2/3 of the entire hardcore history on World War I at the same time. So if you're ever backlogged on podcasts, starting an incredibly long walk is a great thing to do.
True. Yeah, most of them is like 60 kilometers in one day, but after that it was like broken for a week. I couldn't like walk straight. Okay, Proto, what's your like preferred way of moving around?
I'm also on walking maxi. This is why I like DevConnect better than DevCon. Although I could have picked a place this year, or time of the year that there's more sun. But I did walk pretty much everything during DevConnect. Much nicer.
Okay, so if there's a conference in an hour and it's like a 45-minute walk, would you walk or would you take a taxi?
If I don't have to rush for a talk, I'll be walking.
Okay, cool. That's nice. Brecht, your preferred way of moving around?
Yeah, same as Vitalik, I guess. I also don't have like a driver's license, so yeah, for me it's like walking or biking. But I guess, well, my mom would say that I would have to do more of those in any case. But yeah.
Okay, guys. Our time is up. I want to thank all of you, the three of you, for being here, for accepting the invitation to come to this Twitter space to talk about multi-proofs and answering some of these fun or strange questions. Yeah, thank you very much, Proto, Brecht, Vitalik. Thank you very much. And yeah, for our community and the listeners, I hope you enjoyed the Twitter space. And yeah, thank you for your support, and see you next time.
Yep, thank you too.
Yep, thank you, Archie.
Thank you. Bye-bye.
Bye.